Welcome to this video on Strands Agents. This is my second video on my Strands Agents series, and in this video we are going to dive into tools. Tools are a very powerful way that allow agents to use things that are outside of the large language model. In the last video, we did a set of agents that were just relying on instructions that would be passed along with the prompts into the large language model, and the large language model would then proceed to give us an output. For example, the joke bot, we gave it an instruction that it would basically always make a joke. And once we gave it an input, it would try to make a joke out of it. Now, tools allow us to define functions, in this case Python functions, that these agents can use to perform calculations or data processing. And the basic version of this is just kind of a wrapper, as it is here on the screen, around a library function. So for example, here we have a library that is called random, and we are going to use a function randint. The most important point here is this decorator at the top, which is indicating to the Strands Agent framework, hey, this is something that an agent can use. The agent then will proceed to understand what this function does and use this piece of code when it's necessary. Now, these are very basic functions, but you can also access external APIs or services. In the next video, we are going to build an agent that can Google. So this is a very powerful API. It can ask information from Google and then it can return with the result. And that's obviously a much more powerful tool than just generating random numbers. But it serves as an example here. And for this video, we are going to stick to these rather simple ones so that you can understand the most basic principles of defining tools. Of course, you can also interact with databases or file systems and any other system and execute also custom logic. The last part of this notebook will also show you or ask you to write such code. So without further ado, let's get started and start building. If you're interested and want to follow along, the URL with the notebook that I'm going to use is under this URL, and you can also use the QR code to access the GitHub repository. Let's switch to the notebook. This is again Visual Studio Code, just like the last time. And when you download everything from this GitHub repository, you will get a bunch of notebooks. We are going to focus today on the second one, Tools and Agents. This is the notebook that you are seeing here on the screen. The most important point at the beginning is that you have all the right libraries installed. In the previous video, we were just relying on the Strands Agents package, but now we need the Strands Agent tools and the Strands Agent builder, along with the Boto 3 SDK for the Amazon Web Services. We are going to use Bedrock again as the underlying foundation model provider. If you want to use your own laptop, I suggest that you wait a couple of days so I can upload the notebook that has the Olama implementation, which runs on your laptop. The second part is getting authenticated to Bedrock. And of course, you can use the API keys as we did this the last time. This time around, I'm not going to use the API keys because I have installed the AWS CLI on my computer here, and I can just rely on a profile, which in this case is called default, and I'm going to run it in US West 2. But if you want to use the API method that I've shown in the last video, I've walked you through step by step through this authentication process. I suggest you get again an API key, you paste it into these quotation marks here, and then you run it through with the API key and use the API key for authenticating to Bedrock. Once you have a green tick mark here, you should be good to go. The first cell in this notebook is basically repeating what we did the last time. We create an agent, in this case, the Python expert agent. So the joke agent and the pirate agent and a bunch of others in the last video. This Python expert has no tools and it doesn't use any tools to create that answer. When we start building tools, the first thing is we need to define the tools. And as I noted on the slides, there is this decorator. It's called addTool. And the first function that we are going to define is that the current time. And we use this using a library function, and then we return it in a very common format with the year in front, the month, the day, and then hours, minutes, and seconds. It's a very simple function. basically a one-liner of a function. The second one is the one that I had on the slide. This is the generate random number, a tool that has an interval, in this case, min-val and max-val, out of which it picks a random number. The default values for this interval are 1 and 100. The third one is implemented in a similar way. It's using or calculating the factorial. This is also another function that is defined in the math package, and you can just use it like this. The important point here is twofold. First of all, factorials of negative numbers cause an error. And the second one is there is no type hint here. So if you look at the above function definitions, they all said this minimum value is an integer, this maximum value is an integer, and so on. In this case, we don't have this, and I will show you that this will cause an error and why this is important. The fourth tool that we are going to implement is the calculate compound interest tool. It's basically about interest and how much money you get after a certain amount of time. You don't have to understand the specifics of the formula, but what I want to note here is, of course, you can use other types, like in this case, numbers for parameters. So you're not bound to integers or strings or whatever. You can use any type here. Also important, you can return complex structures. In this case, we are returning basically a dictionary or a JSON that contains a bunch of numbers and rounded numbers and so on. And it will allow the agent to give us a very detailed answer about the interest and the money that we get after a while. Again, you don't have to be an expert on finances. Just take this as an example of a function that takes a bunch of inputs and gets a dictionary back instead of just a single value like the one here above with the factorial. Now let's define those functions and get to use them. So the first step towards using a tool is that we define an agent, just like we did before. So this is all pretty much the same standard that we had before. We create an agent, we have a system prompt, we give it a bunch of instructions. But the new part here is what's below. We basically say, hey, here's a list of tools that you can use. And it's basically listing all the 4 functions that we've defined above. Now, the important point here is that we are not saying, hey, if you get asked about the time, you need to call this function. And if you get asked about factorials, you need to call this function. This is something that the LLM does on its own, or the agent framework does this mapping on its own. And it will choose a combination of tools that are the best fit for answering a given prompt. So without further ado, let's define that agent. Basically, we are just giving it pointers to the different functions that we've defined as tools above. Now let's test this. And we have a bunch of different questions that we are going to ask. The first one is, what time is it now? The second one is, we want to generate a random number. And here it's important that we are not saying from which interval. So it's going to use the default values between 1 and 100. That's something that the agent will do on its own. Then we are going to ask it to generate 3 random numbers between 1 and 200. So we are giving it a specific interval. The fourth one is, what's the factorial of 7? Then we are going to ask it, hey, if I have $10,000 at 5% annual interest rate for 10 years, how much will I have? Let's look at the output. We get the current time, that's 10:21 a.m. on July 20th. Then we have the random number as expected, or from the interval between 1 and 100. And the agent even explains here that it uses the default range. The question 3 is generate 3 random numbers. It specifically says you need to use this tool 3 times. As you can see, the numbers here are between 100 and 200. So it's 169, 143, and 129. If you run it, of course, it will have different numbers. What's the factorial of 7? As you can see here, it says, I apologize for the error. It seems there's a technical issue with the factorial calculation method. It still tries. The large language model that we're using, Sonnet 3.7, is powerful enough that it can do it on its own. It doesn't need a tool here. So it will create this kind of output and it will provide us with the answer, which is correct. But the point here is it can't use the tool correctly. It figured out, hey, the tool has something that's wrong. As noted, we didn't provide a typing hint. When we look up here at the definition of the factorial function, we didn't have this colon and, for example, integer here. And this basically means that Strands will try to pass a string into this function. This function here that is then using this input expects an integer. So it will try to run this parameter similar to an integer, but it fails because it got passed a string. There are different ways how to fix this. One way to fix this would be that we write a type hint here and say, hey, make this input an integer. The other way would be that we convert the input parameter before passing it to the library function from a string into an integer. I'm going to stick here with the type hints, but if you want to fix this in a different way, feel free. There are many different ways. Let's redefine that and go back down to the agent definition, redefine the agent, and let's rerun these so that we can see that this actually worked. Again, it creates the current time, it creates random numbers. So all of this is pretty straightforward, similar to what we had before. What we're expecting now is with the question about the factorial here, that we would get a tool usage similar to here. So we get tool number 8 and so on, and that we would get a corresponding answer from the agent. Let me make this scrollable. And as you can see here, it actually used the tool 13, calculate factorial. It did this successfully and it gave us the same result as we had it before. The last one is the one about the interest rate. And here it says, hey, our money is going to grow from 10,000 to 16,479 cents. Keep this number in mind. Let's switch back to see if this is actually right. I have the compound interest calculator here. I'm using the same inputs that I used for the functions, $10,000, no monthly contribution, length of time is 10, estimated interest rate 5%, and we are going to calculate this, and then we are going to see that actually what we calculated, the 16,479 cents, is actually right. When we try to do this with a less powerful model, in this case, I'm going to use a Llama 3 8B model, and I'm going to give it the same input directly without a tool. It's going to give us a number that is almost right. You could be fooled into thinking that this result is actually right. It gives you a computation, but the number that it gives here in the end is wrong. So the 16,191 191 and 19 cents is not the right number, as we've seen. It's important to understand that particularly with less large models, you will struggle to get the right answer to questions that are like this. This gives you a hint into two things. The first one is large language models are not good at math. And this is why you have tools, or one of the key reasons for having tools is if you need to make any kind of computation, it's always better to use a tool and do this outside of the large language model instead of trying to do this in the large language model, which could go wrong. Secondly, if you have a very large model, like for example, the Sonnet 3.7, these models are going to be able to do this, but they are going to create quite a number of tokens for reasoning to actually come up with this, and it will take a while, whereas the tool takes a few milliseconds to execute. Therefore, it's much cheaper. You can use a small model for getting the same result. Tools are also a way of saving costs. I've seen a lot of tool usage for reducing the cost of in production workloads in practice. Let's see how we can combine this with the context or the memory that we've introduced in the last notebook. In the last notebook, we had a conversation flow, and there we could basically say, hey, you refer back to something that you said in the previous conversation. And we are going to do the same, and we are going to do it with the combination of tools, and you will see that this actually works quite the same. So we are going to create another conversation agent, and we are going to give it a system prompt, and we're going to tell it, hey, you have two tools, the random number and the calculate factorial. And then we are going to ask it a bunch of questions and prompts. Hey, I'm learning factorials. Can you calculate 5 factorial for me? How is it different from 6 factorial? So you're making a reference back to the previous computation and you're asking it, hey, what's the difference? This shows you that you can use tools in combination with the context. So the overall setup is the same. Now let's look at the response. Hey, I'm learning about factorials and so on. And the first answer is basically explaining you what factorials are. Now, calculate 5 factorial is the same as we did above. And you can see that it's using the factorial tool for doing this. Factorial 5 written as 5 XARC equals 120. It gives you the calculation and so on and so on. So this is basically the same thing. Now we are referring back to the previous computation, and it knows that it needs to give us the difference between 5 factorial and 6 factorial. So in this case, it computes 6 factorial using the tool, and then it gives us a difference. So it basically tells us, hey, this is just 6 times 5 factorial, so it's 6 times 120. Of course, the whole text here explains you more about the multiplication and so on and so on. The important message here is you can use the context window and the whole input handling similar to what we did the last time with tools by extending your agents with a list of tools. The other thing is that Strands is very good at handling errors. We previously had already an error where we passed the string to a function and that caused an error, and it was handled quite gracefully because the large language model then jumped in and said, hey, I'm going to be able to answer that question. But you can also give it different other values. So for example, factorial of -5, that's undefined, and we have corresponding code, and then basically it tells us, hey, this is not possible, and therefore I'm going to give you a text instead of just a number. So it detects that there's something wrong here and will basically provide you with a graceful way of handling that error. Same with the generation of a random number between 150. It expects the smaller number first and the larger number second. And that's basically also identified by Strands Agent. Same is here with the interest rate on negative $1,000 or empty. So you can see that Strands is actually quite good at picking up things that are not handled by the function. So you don't need to have a lot of excessive error handling code in your functions. It's obviously better if you have it. Strands is actually quite good at handling errors and inputs that are not possible for the tool usage. The last step, I encourage you to go and build yourself some stuff. And in this case, I would ask you to write a research assistant, which uses 2 tools, the word count tool and the calculate reading time tool. Pretty straightforward. You only need to write 2 pieces of code here. I've left them out for you to figure that out and do it yourself. You can implement both of these functions. You can give it a bunch of tools and play around with it. I hope you had fun repeating or getting an introduction into agents. Now go build. If you like this video, leave a like in the YouTube channel, maybe even a subscription. And thank you for your attention.